So today we are going to solve a first order linear equation. So how can we determine if it is linear? So a DE is said to be a linear if we can actually put the differential equation in this form, wherein dy over dx plus p of x y is equal to q of x. So this is linear of y. So if it is formed like this, we will use this formula. If it is linear of y, we will use this formula. Y e raised to integral of p of x dx is equal to integral of q of x e raised to integral of p of x dx dx. While if it is linear in x, we can also use this formula. Xe integral of p of y dy is equal to integral of q of y e raised to the integral of p of y dy dy. Let's proceed to linear equation. So this is our problem number 2. So x dy plus x squared minus 3y dx is equal to 0. So we also have a condition here. So we need to eliminate this one, or the x here, then dx, so we need to transpose the dx. So divide both sides to 1 over x dx. So the x here will cancel. So dy over dx plus x squared minus 3y over, so dx, then or x dx, so cancel, so equal to 0. dy now over dx is plus 2x squared minus 3y over x. So as you can see, we can separate them, right? So dy over dx plus x squared over x minus 3y over x. So we can cancel this one. So dy over dx, dy over dx plus x minus 3y over x, so is equal to 0. Then we can transpose x here. So dy over dx minus 3x y is equal now to negative x. So as you can see, this is form in linear of y, linear in y. So we can use now, so our p of x, so our p of x now is negative 3x. Then our q of x is equal to negative x. So we can now use the formula of linear in y. So we have now the p of x and the q of x. So we will now apply the formula which is linear in y. So ye raised to, raised to p of x dx is equal to integral of q of x e raised to integral of negative, p of x dx. So we will now input the p of x and the q of x. So ye integral of p of x is negative 3 over x dx is equal to integral of our q of x, which is negative x, e raised to integral of p of x. Our p of x is negative 3x dx. So integral of negative 3 over x dx is 3 ln. So ye is equal to negative 3 ln of x is equal now to integral of negative xe. So integral of negative 3 over x is negative 3 ln of x dx. So this will become ye ln of x negative 3 is equal now to integral of negative xe raised to ln of x negative 3 dx. So we can now cancel the ln here. So y is equal now to So x negative 3 is equal to, so integral of negative x times this will become 1 over x cubed. Or we can now so we can cancel this one. So we can y is equal to, we can put the x negative 3 here, x positive 3. So is equal now to integral of, so is equal now to integral of negative 1 over x squared x squared dx. So integral of negative 1 over x squared, so y over x cubed is equal to integral of negative 1 over x squared is 1 over x plus c. So this should be in terms of y, so we need to eliminate the x cubed here. So x cubed, so y now is equal to, so x squared plus cx cubed. So remember, we have a condition, so we will now apply our condition to the value of our y. So first is y negative 1 is equal to 1. So y is 1 is equal to, our x is negative 1 squared plus c negative 1 cubed. So 1 is equal to 1 plus c negative 1. So 1 minus 1 is equal to, so 1 minus 1 is equal to c. So our c is equal to 0. So we can conclude that y is equal to x squared. So for our next condition, y1 is equal to negative 1. So negative 1 is equal to 1 squared plus c then 1 cube. So, negative 1 is equal to 1 plus c. So, our c now is equal to negative 1 minus 1. So, c is equal to negative 2. So, we can conclude that our y is equal to x squared minus 2x cubed. So, we satisfied our condition. So, we can now conclude that y is equal to x squared. So, x now is, we can conclude that x is less than or equal to 0. Then, x squared. So x squared here. So, x squared minus 2x cubed. So, x squared. X squared minus 2x cubed. 2x cubed. So, we can conclude that 0 is less than or equal to x. So, that is our final answer.